There is a machine in almost every bathroom in the world that nobody has ever had explained to them. You stand on it, half awake, and a number appears. And if somebody asked what that number measures, you would say how much of you there is, how much matter. That is not what it measures. It never has been. A cup of hot coffee weighs more than the same cup gone cold, and nothing was added to it. A fresh battery weighs more than a dead one, and a hydrogen atom, one proton, one electron, nothing else in there, weighs less than that proton and that electron weighed apart. Nothing escaped. Count them afterwards and both are still there, and the total has gone down. The reason is written into the most famous equation ever produced by a human being, and the sentence attached to it for 80 years is wrong. By the end of tonight, you will know exactly what it actually says. Before we begin, if this slow, unhurried way of taking an idea apart is how you like to fall asleep, a like or a subscribe would mean a great deal. It is a small thing for you, and it means the world to me. Now, let's ease in. There is a machine in almost every bathroom in the world that nobody has ever had explained to them. You stand on it in the morning, half awake, and a number appears. You have been reading that number your whole life. You were weighed on the day you were born, before you had a name, and somebody wrote the figure down. And in all the years since, in doctors' surgeries, and airport check-in queues, and kitchens where somebody was measuring flour, not one person has ever stopped you to say what the number is actually a measurement of. You would probably say, it measures how much of you there is, how much matter, how much stuff. That is the intuitive answer, and it is the answer almost everyone gives, and it is the answer that most physics teachers gave for a very long time, because it is close enough for a Tuesday afternoon. It is not what the number means. It has never been what the number means. And the reason it is not is written into the most famous equation ever produced by a human being, an equation that almost everyone can recite, and almost nobody has been told the actual content of. Let me give you the fact that broke this open for me, and then we will spend the next 2 hours understanding it properly. A hydrogen atom is the simplest object in chemistry. One proton, one electron. That is the entire inventory. There is nothing else in there. No third particle hiding in the corner. Nothing that leaks out. Nothing that gets used up. A proton and an electron held together, and that is a hydrogen atom. Now take a proton on its own and weigh it. Take an electron on its own and weigh it. Add the two figures together, and then weigh a hydrogen atom. The hydrogen atom weighs less. Not the same. Less. The two particles, joined together into an atom, weigh less than those same two particles weighed when they were apart. Nothing was removed. Nothing escaped. Count them afterwards and they are both still there, the proton and the electron, exactly one of each, and the total is smaller than it was. I want you to sit with how strange that is, because it is easy to hear it and let it slide past. Imagine putting 2 apples on a scale, then putting them in a bag, then weighing the bag, and finding that the bag with the apples in it weighs less than the apples did. You would not say the apples had changed, you would say the scale was broken. The scale is not broken. This is not a measurement error, not an approximation, not a rounding artifact. It is a real, calculable, measurable difference, and it is not just hydrogen. Every atom on the periodic table weighs less than the particles inside it. Every molecule weighs less than the atoms it is made from. The Earth weighs less than the dust it condensed out of by about 2.5 trillion tons. This is a universal rule, and there is no object anywhere in the universe that escapes it. And then, running in the opposite direction, there is a second family of facts that are just as strange. A cup of hot coffee weighs more than the same cup of coffee once it has gone cold. A fresh battery weighs more than a dead one. A wound-up watch weighs more than a watch that has stopped. A spinning wheel weighs more than a still one. Not because anything was added to them. Nothing was added. They just have more energy inside, and the number on the scale went up. And here is a detail that ought to unsettle anyone who thinks this is a modern subtlety. Human beings have been weighing things for about 5,000 years. The balance scale is older than writing in some places. Merchants in Mesopotamia were setting stone weights against grain long before anyone had a word for an atom. And every one of those transactions, and every transaction since, rested on the assumption that the pointer was counting how much material was on the pan. That assumption was never checked, because for 5,000 years there was no way to check it, and because in ordinary life it gives you the right answer to within a precision no market and no kitchen has ever needed. So here is the shape of the problem. Put energy into something and it gets heavier. Bind something together and it gets lighter. Neither of those makes any sense at all if mass is a count of how much material is present, because in every one of those cases, the material is exactly the same before and after. Same proton, same electron, same coffee, same watch, which means the number on the scale is measuring something else. It has always been measuring something else. And once you know what it is measuring, the most famous equation in physics stops meaning what you were told it means. You know the equation. Everyone knows the equation. It has been on t-shirts and album covers and the sides of buildings. It appears in cartoons as shorthand for a clever person doing physics. It is probably the only equation that most people on Earth could write down from memory. And the sentence that gets attached to it, the one that appears in documentaries and textbooks and museum placards, is that mass can be converted into energy, that a small amount of matter can be turned into an enormous amount of energy, that this is what happens in the sun and in a reactor and in a bomb. That sentence is wrong. Not simplified, not approximate. Wrong, in a way that changes the entire picture of what the physical world is made of. And I am going to show you exactly where it goes wrong and what the equation actually says instead. But I am not going to tell you the answer yet, because it will not mean anything to you if I say it now. Said cold. It sounds like a technicality. It sounds like a physicist being fussy about vocabulary. It only becomes the thing it actually is once you have walked through about a dozen ordinary objects and watched the old picture fail on every single one of them. So that is the shape of tonight. We are going to start with a wristwatch and a battery and a cup of coffee, and we will find that all of them are doing something no one ever mentioned. We will seal a torch inside a mirrored box and watch a scale refuse to move. We will go to the sun and count 4 million tons a second and find that nothing was destroyed. We will go inside a hydrogen atom and find out why it is lighter than it should be. We will go inside a proton and find, honestly, almost nothing there at all. And at the very end, we will take the hardest case physics can offer, a particle meeting its own antiparticle, and both of them ceasing to exist. And we will discover that even there, the books balance perfectly and nothing was converted into anything. By the end of tonight, you will know exactly what the most famous equation in physics says, why almost everyone is wrong about it, and what that machine in your bathroom has actually been telling you every morning of your life. Let us start where Einstein started, which, it turns out, is not where you think. Einstein never wrote E equals mc² in 1905. That is not a technicality. It is the first clue, and it has been sitting in plain sight for over a century in a paper that anyone can read in an afternoon. Here is the situation in the autumn of that year. Einstein is 26 years old. He is working as a technical expert, third class, at the patent office in Bern, examining applications for electrical devices. He is not a professor. He does not have an academic position of any kind. He has a wife and a small child and a job that occupies 6 days a week, and in his spare hours, over the previous months, he has produced 4 papers that will restructure physics. In March, he explained the photoelectric effect by proposing that light comes in discrete packets, which is the seed of quantum theory, and the work that will eventually get him the Nobel Prize. In May, he explained Brownian motion, the jittering of pollen grains in water, in a way that settled the question of whether atoms are real. In June, he submitted a paper called On the Electrodynamics of Moving Bodies, which is special relativity, and which throws out absolute time. And then in late September, 3 months after the relativity paper, he submits a fourth. It is 3 pages long. It has a question mark in the title. It is called, Does the Inertia of a Body Depend upon its Energy Content? Let me put you in that room for a moment. It is evening in Bern. The patent office is closed. Einstein is at a desk with paper and a pen, and he has already sent off the paper that dismantles simultaneity, and he cannot leave it alone. Something in the relativity argument has kept nagging at him, so he sets up the simplest thought experiment he can think of. Take a body sitting still. Let it emit 2 flashes of light in exactly opposite directions, so that the recoils cancel and the body does not move. Now watch the same event from a train going past. Do the accounting both ways. He does the algebra. It takes barely a page. And the 2 accounts do not match, unless the body has lost mass. Unless simply letting light leave has made the object lighter. He writes the conclusion in a single, clean sentence. If a body gives off the energy L in the form of radiation, its mass diminishes by L divided by the square of the speed of light. And then, because he cannot help himself, he generalizes it in the next line to all forms of energy, on no evidence whatsoever, except that it would be strange if light were special. He is not sure at all. In a letter to his friend Conrad Habicht that summer, he describes the line of thought as amusing and fascinating, and admits he cannot know whether the dear Lord is laughing at him and leading him around by the nose. He ends the paper with the only test he can think of, that radium salts, which put out far more energy than anyone can account for, might show the effect. And then he puts down the pen. 3 pages, no data, 1 thought experiment about a body emitting 2 flashes of light. Now here is what matters, and here is what gets lost. Look at the form of what he wrote. His algebra produces mass on the left-hand side and energy on the right. Mass equals energy divided by the speed of light squared, not the other way around. That ordering is not decoration. In physics, when you write an equation, the thing on the left is generally the thing you are explaining, and the things on the right are what you are explaining it with. Einstein's equation explains mass. Mass is the derived quantity here. Mass is the output. Energy is the input. Now write it the way everyone writes it, with energy alone on the left, and something quietly reverses. Suddenly it reads as a statement about energy, as though energy were the thing being produced, and mass were the raw material producing it. Suddenly it sounds like a recipe. Take mass, multiply by a very large number, receive energy. That is not what the paper says. The paper says the exact opposite. The paper says, here is where mass comes from. And there is a second word that gets lost, and it is the more important one. In the closing generalization, Einstein does not write that a body's mass contains energy, or stores energy, or can be traded for energy. He writes that the mass of a body is a measure of its energy content. A measure. That is a very specific kind of word. A measure is not a substance. A measure is a number you attach to a thing to describe a property it has. The reading on a thermometer is a measure of thermal energy. Nobody thinks a thermometer converts degrees into heat. The brightness of a lamp is a measure of the power going through it. Nobody thinks brightness is a fluid the lamp is filled with. Einstein is telling you, in the last line of a 3-page paper written by a patent clerk in his spare time, that mass is a reading, not a substance. A reading. And I want to be careful here, because it would be easy to make this sound like word games. It is not word games. The difference between a substance and a measure is the difference between two completely different pictures of what the world is made of. If mass is a substance, then the universe is full of stuff, and energy is something that stuff can be traded for, and there is a boundary somewhere between the two where the trade happens. If mass is a measure, there is no boundary and no trade, because there was only ever one thing there, and mass is a number describing it. Those two pictures make different predictions about almost everything we are going to look at tonight, and only one of them survives contact with a hydrogen atom. It took him decades to get people to hear it, and in a real sense he never quite managed. He came back to the derivation again and again over the next 40 years. There are at least 7 distinct Einstein derivations of this relation, one from 1935, built purely on conservation of momentum, another from 1946, aimed at people with no mathematics at all. Some of that was because Max Planck had objected that the original argument was only approximate, but some of it, you get the sense, was because Einstein could see the equation escaping into the world, wearing the wrong meaning, and he kept trying to put it back. And the equation did escape. Through the 1920s and 30s, it was a technical result inside relativity, known to specialists, not famous at all. It became the most recognizable equation on Earth in the 1940s, and it became famous for exactly one reason: nuclear weapons. It entered public consciousness, attached to a story about matter being destroyed to release energy, and that attachment has never come off. So when someone tells you that E equals mc² means mass converts into energy, what they are actually reciting is a piece of wartime journalism, not a piece of physics. We are not ready yet to say what it does mean. That answer is closer than it was, but it has not been earned. Before we can say it, we have to watch the old picture fail, not once, but over and over, in objects sitting in your house right now. Let us start with something on somebody's wrist. Take 2 mechanical wristwatches, not quartz, the old kind, with a mainspring you wind by hand and a balance wheel that swings back and forth about 5 times a second. Make them identical, not similar. Identical, atom for atom. Same brass, same steel, same jeweled bearings, same number of every kind of atom in exactly the same arrangement. If you have ever wanted a completely fair comparison, this is it. Now wind one of them up and let it run. Leave the other one stopped. According to Einstein, the running watch is heavier. Let me be clear about what is not happening. Nothing has been added to the running watch. No metal, no oil, no dust, no particle of any kind. If you counted every atom in each watch, you would get exactly the same inventory. The 2 objects contain precisely the same material, and one of them weighs more than the other. Why? Because the running watch has energy inside it that the stopped one does not, and every single one of those forms of energy shows up on the scale. Start with the mainspring. Winding a watch means twisting a flat steel ribbon into a tighter coil, and steel resists being twisted, so you had to do work to get it there. That work is now sitting in the spring as elastic potential energy, the strain in the metal, the electrons in the crystal lattice, pushed slightly out of the arrangement they would prefer. It is stored, and it is real, and it is measured in joules. Then there are the moving parts. The balance wheel is oscillating, the gear train is turning, the hands are sweeping. All of that is kinetic energy, small, but not zero, and continuously replenished from the spring. And then there is the friction. Every pivot in that watch rubs, very slightly, against its bearing. The oil shears. And that means the running watch is fractionally warmer than the stopped one, by an amount far too small to feel, but real. Warmth is not a separate substance. Warmth is the atoms of the metal jiggling around their positions a little more energetically, which is to say, warmth is kinetic energy again, just randomized and at a much smaller scale. Elastic energy in the spring, kinetic energy in the gears, thermal energy in the case, 3 different looking things, and Einstein's relation treats all 3 identically. You add up every joule inside the watch, wherever it is sitting, and whatever form it has taken. You divide the total by the speed of light squared, and that is how much extra mass the running watch has. I want you to notice what has just happened, because it is easy to nod along and miss it. We have not gone anywhere near a nucleus. There is no radioactivity here, no particle physics, no exotic conditions. This is a wristwatch on a bedside table, doing the ordinary thing that wristwatches do, and it is changing its own mass as it runs. Let me put you in the room with it. Imagine a balance so sensitive, it is not physically possible to build. And I want to be honest with you about that, because we will come back to it. It exists nowhere. But imagine it, a single pan, and a needle, and enough sensitivity to register a change of 10 femtograms, 10 quadrillionths of a gram, about 1% of the weight of a single bacterium. You wind the watch fully, and set it on the pan. The needle settles. Then you sit down in a chair in the corner of the room, and you watch. Nothing appears to happen. The hands move. The balance wheel makes its small sound. Hours pass. And across those hours, slowly, without a single atom leaving the pan, the needle drifts. Not because anything is evaporating, not because of air currents, or dust, or temperature in the room. Imagine all of that controlled away. The needle drifts because the mainspring is unwinding, and the energy that was locked in that steel is being paid out into motion and then into heat, and the heat is leaking through the case into the air of the room and away. By the time the watch stops, about 36 hours later, the needle has come to rest in a slightly different place. The watch on the pan is the same watch. Every atom present at the start is present at the end, and it weighs less than it did. The whole day, you were not watching a watch run down. You were watching energy leave a system, and you were watching a number follow it. Now, that balance does not exist, and it is worth being precise about why. A typical mainspring stores on the order of 1 joule. Divide 1 joule by the speed of light squared, and you get about 11 quintillionths of a gram, the 10 femtograms we just described. The watch itself weighs perhaps 50 grams, so the change is roughly 2 parts in 10,000 million. The finest mass comparators ever built, the ones used by national metrology institutes to compare kilogram standards against each other, reach about 1 part in 10,000 million. That sounds close until you notice it is 100,000 times short. So we cannot weigh it. That is a fact about our instruments, and it is not a fact about the watch. The difference is not undetectable in principle. It is not a theoretical fiction. It is a specific number of femtograms, computed from a measured amount of energy by a relation that has been tested to a few parts in 10 million in other settings, and it is sitting there in the object, whether or not anyone can read it. There is something almost tender about that gap between what is true and what is measurable. Physics is full of quantities that were predicted long before anyone could see them, and the usual story is that the instruments eventually caught up. Here they have not, and in this particular case they may never. We know the number. We can compute it to as many decimal places as we like, and there is no plausible machine, now or in any laboratory anyone has sketched, that will ever put a needle on it. The watch keeps its secret, not because the secret is deep, but because the exchange rate is merciless. And we will come back to that exchange rate very shortly, because it is the reason none of this was noticed for 5,000 years. And this is the point where somebody usually asks a very good question, so let me deal with it now. If the hands are moving, does that mean the minute hand itself is heavier? Is the moving part carrying extra mass around with it? No, and the distinction matters enormously for everything that follows. When a modern physicist says the word mass, they mean the mass of a thing measured in the frame where it is sitting still, what used to be called rest mass, and what is now just called mass, because there is no other kind worth having. The minute hand, considered on its own and measured by someone travelling alongside it, has exactly the mass it always had. Its material has not changed, and neither has its rest mass. What has changed is the mass of the whole watch, considered as one system, and that turns out to be a completely different quantity from the sum of the masses of the pieces. Hold on to that, because it is the hinge the rest of tonight turns on. The mass of a composite object is not the sum of the masses of its parts. It depends on two further things: how the parts are arranged relative to each other, and how they are moving inside the whole. Change the arrangement, and you change the mass. Change the internal motion, and you change the mass. The inventory is not enough. That is a genuinely strange sentence, and it deserves a second reading. If somebody hands you a sealed box and tells you exactly which atoms are inside it, and how many of each, you still cannot tell them what the box weighs. You would need to know how those atoms are arranged, and how fast they are jiggling, and whether anything in there is wound up, or compressed, or spinning, or warm. Two boxes with identical contents lists can sit on identical scales and give different readings, and neither scale is wrong. We have just watched it happen with a wristwatch. And if it happens with a wristwatch, it happens with everything. So let us find out how big the effect actually is in the objects around you. Let us go around an ordinary house and put numbers on this, because a rule you cannot quantify is not really a rule yet. It is just a slogan. Start in a drawer. There is almost certainly a battery in it. A standard alkaline AA cell holds roughly 10,000 joules of chemical energy, about 2.8 watt-hours, which is the figure printed in the datasheet. That energy is stored in the arrangement of zinc and manganese dioxide, in electrons sitting in configurations they would rather not be in, waiting for a circuit to let them relax. 10,000 joules, divided by the speed of light squared, comes to about 1/10 of a nanogram. So a fresh AA battery weighs about 1/10 of a billionth of a gram more than the same battery does once it is flat. The cell weighs 23 grams, so we are talking about a difference of roughly 5 parts in a million. It is not measurable. It is entirely real. Go to the kitchen. Fill a kettle with a liter of ice-cold water and boil it. To raise 1 kilogram of water by 100 degrees takes about 418,000 joules. That water, at boiling point, weighs about 4.7 nanograms more than it did when it was cold. Same water, same number of molecules. Nothing added but heat, and heat has weight. Pour it into a cup. As that coffee cools on the desk over the next half hour, it is not only losing temperature, it is losing mass, about 9/10 of a nanogram for a 1/4 kilogram cup, dropping 80 degrees. The warmth radiating off the surface of your drink is carrying weight out of it and into the room. Look at the phone in your hand. A 15 watt-hour battery holds about 54,000 joules when it is full. Your phone at 100% is about 6/10 of a nanogram heavier than your phone at 0%. Every night, plugged in beside the bed, it gets fractionally heavier. Every day, it gets fractionally lighter. It has been doing that since you bought it. Go outside to a power station or to any large machine with a flywheel storing 10 megajoules of rotational energy, a serious industrial device, the kind used to smooth out load on a grid, is about 1/10 of a microgram heavier when it is spinning than when it is at rest. That one is only 3 or 4 orders of magnitude below the finest laboratory balances. Of everything in this list, it is the closest anyone has come to being able to weigh the effect directly in a piece of machinery. Even you, an adult burning 2,000 kilocalories a day, is processing about 8.5 million joules. That works out to about 93 nanograms per day of mass difference, all of which leaves as heat and infrared light. You have been very slowly radiating weight into every room you have ever sat in. Take it up a scale, to the planet. The Earth absorbs about 170,000 million watts of sunlight, and radiates almost exactly the same amount back out into the dark. Almost. In the current climate, there is a small net imbalance, of order 1,000 million watts, and in the strictest energy content sense, That means the planet is gaining a few kilograms per second. It has no practical consequence whatsoever. It is nothing next to the tons of meteoritic dust arriving daily, or the hydrogen escaping from the top of the atmosphere. But the books balance perfectly, and they balance in exactly the way the rule predicts. And it works in reverse in the most ordinary places. A compressed spring in a mousetrap is heavier than a released one. A drawn bowstring is heavier than a slack one. A stretched rubber band is heavier than a relaxed one. And if you have ever noticed that a rubber band warms slightly when you stretch it quickly and cools when you let it go, you can feel this on your lip. Then you have felt energy moving between two of the forms we are talking about with your own skin. So here is the pattern, and it is completely consistent. Every time energy goes into something, the something gets heavier. Every time energy leaves, it gets lighter. Chemical, thermal, elastic, kinetic, rotational. The accounting does not care which. Joules are joules, and every single one of these numbers is absurdly small. That is not a coincidence, and it is not a disappointment. It is the whole reason this was hidden from the human race for as long as it was. The reason is the constant. The speed of light is about 300 million meters per second, and the equation calls for its square, which is about 90,000 million joules per kilogram. Written out, 9, followed by 16 zeros. That number is an exchange rate, and it is the most brutal exchange rate in nature. 1 gram of mass difference corresponds to about 90 million joules, roughly the energy released by 21,000 tons of high explosive. Go the other way, and it is even more vivid. A kilowatt-hour of electricity, the amount that will run an oven for an hour, corresponds to a mass difference of about 40 picograms, 40 trillionths of a gram, for enough energy to cook a meal. There is a nice way to feel how lopsided that is. If you wanted to make a kitchen scale visibly move using this effect alone, say by a single gram, you would need to put roughly the annual electricity consumption of a small city into the object you were weighing, all at once, and keep it there. Meanwhile, the total electricity generated by the entire human species in a year, all of it, everywhere, corresponds to a mass difference of about 3 tons. 3 tons, for a civilization's worth of power. This is why nobody noticed. Not because the effect is subtle in principle, but because the conversion factor between the energy scales of human life and the mass scales of human life is so extreme that the two never met. A blacksmith heating iron for 40 years was changing its mass every single day and had no possible way of knowing. A merchant in Mesopotamia setting stone weights against grain 5,000 years ago was, in the strictest sense, measuring the energy content of the grain, and there is no experiment he could have done to find out. And that is the sentence I want to leave hanging for now, because I do not think we have earned it yet. Every time you have put something on a scale, what you were reading was not a count of material, it was something else. It was a number that goes up when you heat a thing, goes up when you compress a thing, goes up when you wind a thing, and goes down when you let it cool. You can probably see where that is heading. Do not let me say it yet. There is a very large obstacle in the way, and until we get past it, the claim would be premature. Here is the obstacle. Everything we have looked at so far has run in one direction. Add energy, gain mass. That is comfortable. It feels almost like adding stuff. You put something in, the number goes up. Fine. A person could hear all of the above and still walk away with the idea that mass measures how much is present, and that energy is one of the things that can be present. But I told you at the beginning that a hydrogen atom weighs less than the proton and the electron inside it. That runs the other way, and no picture in which mass counts what is there can survive it. Before we get to that, there is one more case, and it is the one that first made me genuinely uncomfortable, because so far, every form of energy we have discussed has been the energy of something, a spring, a molecule, a spinning mass. All of it belonged to objects that had mass of their own. What happens when you put energy into a box, in a form that has no mass at all. What happens when you fill a box with light? Pick up a torch and switch it on. Its mass begins to fall immediately. Not after a while, immediately, from the first instant. The reason follows directly from everything we have just built. The battery inside was holding chemical energy, and that energy was contributing to the torch's mass. We established that with the AA cell in the drawer. Now the circuit is closed, the chemistry is running, and the energy is coming out of the front as light. Light carries energy away, and the moment that energy is outside the torch, it is no longer part of what you would weigh if you put the torch on a scale. So the torch gets lighter as it shines. Nothing was converted into anything. Something left. That is worth pausing on, because it is the first time tonight the word conversion has come up in a case where people usually reach for it. A torch does not convert battery into light. A torch lets energy that was already inside it leave in a different form. The atoms of the battery are all still in the battery afterwards. There are exactly as many zinc atoms in a flat cell as there were in a fresh one. What changed is that the electrons are now sitting in a lower energy arrangement, and the surplus went out through the bulb. Now let us do the experiment that broke my picture of this, and it costs nothing but imagination. Build a box. Make the inside walls perfect mirrors, perfect in the sense that no light ever gets absorbed and no light ever gets out. Seal the torch inside it, switched off. Put the whole box on a scale and note the reading. Now switch the torch on, inside the sealed box, and watch the scale. The reading does not change, not by a whisker. Think about what is happening in there. The torch is doing exactly what it did before. Its battery is draining, its own mass is dropping, joule by joule. But the light it emits has nowhere to go. It crosses the box, hits a mirror, comes back, crosses again. In a box a foot across, that light is making something like 500 million round trips every second, and every scrap of the energy that left the battery is still inside the boundary of the thing you are weighing. So the scale reads the same. The chemical energy has become radiant energy, and the total is untouched, because the total never left. Let me put you inside it, because this is where the strangeness actually lands. You are standing in a sealed box. The walls, floor, and ceiling are mirrored, and outside, unseen, the whole box is resting on a scale. You are holding the torch. You switch it on. Light fills the space around you, and it does not stop filling it, because nothing is absorbing it. Every beam that leaves the lens crosses the box, bounces, crosses, bounces. The air around you brightens and keeps brightening, because the light from a second ago is still here, and so is the light from 10 seconds ago. You are standing in an accumulation. In your hand, the torch is getting lighter. You cannot feel it, but it is true. The object you are holding is shedding mass into the room, continuously, for as long as the beam is on. And outside, the needle on the scale has not moved. It will not move. It will sit exactly where it sat before you touch the switch, no matter how long you leave the torch running, right up until the battery dies. You are holding something that is losing mass inside a system that is not. Before we go on, I should be honest about the idealization, because I do not want to sell you a box that cannot exist as though it could. Perfect mirrors are not available. The very best optical mirrors ever made reflect something like 99.9999% of the light that hits them, which sounds like perfection and is not. A resonant cavity built from mirrors that good can hold light for a few milliseconds, which is on the order of 100,000 round trips, and then it is gone into the glass as heat. But notice that this does not rescue the old picture at all. When the light is absorbed by the mirror, its energy becomes heat in the mirror, and the mirror is inside the box, so the box still weighs the same. You cannot escape the result by making the mirrors imperfect. You can only change where inside the box the energy is sitting. And how much are we talking about? A 1-watt torch running for 1 second puts 1 joule of light into that box. 1 joule is the same figure we met with the mainspring, about 11 quintillionths of a gram. It is the same joule. That is not a coincidence. It is the whole point. The rule does not ask what kind of energy you brought. Now here is the part that I think is genuinely one of the most beautiful facts in physics. A photon has no mass, not a small mass, 0. It is not an approximation or a limit. Masslessness is what allows a photon to travel at the speed of light in the first place, and every measurement ever made is consistent with it, with experimental upper limits now well below 1,000 million millionth of an electron volt. Every photon in that box has 0 mass, and yet the box, taken as a whole, is heavier by exactly the energy of the trapped light divided by the speed of light squared. Massless constituents, massive system. Take the simplest version, 2 photons, each carrying some energy, flying in exactly opposite directions. Individually, both have 0 mass. Compute the mass of the pair, treat it as one system, and you get a value that is not 0. It comes out as twice the energy of one photon divided by the speed of light squared. Now turn one of them around, so both photons travel the same way. Same 2 photons, same total energy. Compute the mass of the pair again, and you get exactly 0. Read that twice. The same amount of light, in the same quantity, gives a system mass, or does not, depending only on which direction the light is pointing. There is no version of mass counts how much stuff is present that survives this. Nothing was added when we turned that photon around. Nothing was removed. The inventory is identical, and the mass changed from something to nothing. The reason is that mass does not add. That is the technical heart of it, and it is worth stating clearly because it is going to explain every single remaining puzzle tonight. Energy adds. Put 2 things together, and the energies sum. Momentum adds 2, though as a direction, as well as an amount. 2 things pushing opposite ways can cancel. Mass does neither, because mass is not a component of anything. Mass is a length. It is the length of a 4-dimensional arrow, whose parts are energy and momentum, and lengths do not add when arrows do. 2 arrows of equal length pointing opposite ways give you a longer arrow, or a shorter one, or nothing at all, depending entirely on how they are arranged. 2 photons pointing opposite ways have all their energy and no net momentum, so their combined arrow is long. 2 photons pointing the same way have all their energy and all the momentum too, and their combined arrow has no length at all. That is not a metaphor I am imposing. That is precisely what the mathematics says. The mass squared of any system is its energy squared minus its momentum times the speed of light, squared. For a single photon, those 2 terms are exactly equal, and the difference is 0, which is why a photon has no mass. For a system sitting still, the momentum term vanishes, and you are left with energy alone, which is the equation everybody knows, appearing for the first time in its familiar clothes as a special case of something more general. And this is not an abstract exercise done only in thought experiments. It is a working tool. When physicists at a particle collider go looking for a new particle, what they usually have is a spray of debris, photons, electrons, muons, whatever survived. They take the energies and directions of those fragments, add up the arrows, and compute the length. If some heavy thing decayed into that debris, the length comes out at the mass of the heavy thing, over and over, in event after event, and a bump appears in the data. The Higgs boson was found this way in 2012. One of the 2 channels that established it was a pair of photons, 2 massless particles, flying apart, whose combined arrow length came out at about 125,000 million electron volts, again and again, until the bump was undeniable. A particle with mass was identified by measuring the mass of a system of things that have none. So, we now have 2 things that ought to be uncomfortable together. Everyday objects gain mass when you put energy into them, and a box of pure light, containing nothing with any mass at all, has mass. Both of those still let you tell yourself a story where energy is a kind of stuff. It is a strained story, but you can hold on to it if you want to. The next one takes the story away, and to get there we are going to leave the room and go and look at the largest torch anyone has ever been able to see. The sun is a torch, and there is no box around it. Everything that leaves it leaves for good, and it leaves at a rate that is worth saying slowly. The sun radiates about 383,000 million watts. Divide that by the speed of light squared, and you find that the sun is losing about 4,260 million kilograms every second. 4.25 million tons. Every second. Since before there was an Earth. It also loses another 1,300 million kilograms a second as solar wind, actual particles, protons and electrons streaming outward past all the planets. But set that aside, because it is not the interesting part. The interesting part is the 4.25 million tons that leave purely as light and neutrinos. Now here is the sentence you have heard, probably in a documentary with slow music underneath it. The sun converts 4 million tons of matter into energy every second. That sentence is wrong, and I can show you exactly where. Go into the core, 15.5 million degrees, 250,000 million times atmospheric pressure. Hydrogen nuclei, bare protons, stripped of their electrons long ago, are moving fast enough and packed tightly enough that, very occasionally, two of them get close enough for the strong nuclear force to take hold. Through a chain of steps, 4 protons end up bound together as a single helium nucleus. 2 protons and 2 neutrons, with 2 of the original protons having turned into neutrons along the way and thrown out a positron and a neutrino each. Now count. 4 nucleons went in, 4 nucleons came out. Not 3, not 3.5, 4. Every particle that entered that reaction is still there afterwards, bound into the helium nucleus. Nothing was destroyed, nothing vanished, nothing was annihilated. So where did the 4 million tons come from? Weigh the 4 separate protons before the reaction. Their combined rest energy is about 3,753 million electron volts. Weigh the helium nucleus afterwards. It is about 3,727 million electron volts. The helium nucleus weighs less than the 4 protons did, by about 26.7 million electron volts, a little under 0.75%. And that difference is exactly, precisely, what leaves as sunlight. Not matter, not stuff. The difference between 2 energy states. The 4 nucleons were loosely arranged before and tightly bound afterwards, and a bound system sits lower than an unbound one, and the drop is what comes out. This is the landslide, and I am going to use that image a few more times tonight, because it is the cleanest one I know. When a hillside collapses, energy comes out, enough to flatten a village. Nobody says the rocks were converted into energy. The rocks are all still at the bottom of the hill, every one of them, and you could go and count them. What was released was the difference in height. The rocks went from a high arrangement to a low arrangement, and the difference had to go somewhere. Nuclear fusion is a landslide. The nucleons are the rocks. Binding energy is the height, and sunlight is the noise the hillside makes. Nothing was converted. Now I want to give you the version of the arithmetic that makes this vivid, because the numbers are lovely. The sun fuses roughly 600 million tons of hydrogen every second. It produces roughly 596 million tons of helium. And people look at that and say, there, 4 million tons went missing. But the same number of nucleons is in the 600 million tons and in the 596 million tons. The count did not change. What changed is that each nucleon is now sitting lower, and the mass associated with all that surrendered binding energy has left the building as light. If you could build a box around the entire sun, mirrored, sealed, letting nothing out, and put the whole thing on a scale, the reading would not change at all. The sun would go on fusing hydrogen for 10,000 million years, and the needle would sit exactly where it started, because the light would still be inside. Same experiment as the torch in the box, different by a factor of 10 to the 26th in scale, and identical in principle. Let me put the loss in perspective, because it sounds alarming, and is not. 4.25 million tons a second is about 2 parts in 10,000 million of the sun's mass. Across the sun's entire main sequence lifetime, 10,000 million years of this, the total radiative loss comes to about 0.07% of its mass. Earth's orbit drifts outward by something like a centimeter a year as a result, which is far too small to matter against everything else going on. The sun will not shine itself away. It will die for entirely different reasons, and long before it has lost 1,000th of itself to light. It is worth knowing how close the 19th century came to a crisis over this, because it shows how much was riding on getting the accounting right. Before fusion was understood, the best available explanation for the sun's output was gravitational contraction, the idea, worked out by Kelvin and Helmholtz, that the sun was slowly shrinking and that the energy released by the infall was what kept it hot. It is perfectly good physics. The problem is that it only buys you about 30 million years, and geologists and biologists were already insisting that the Earth had to be far older than that. For decades, the physicists and the geologists were flatly contradicting each other, and the physicists were the ones with the equations. They were also the ones who were wrong, because the energy source they had not thought of was sitting in the difference between a loose proton and a bound one. And the reason fusion buys so much more time is a number we will meet again later tonight. Hydrogen fusion releases about 0.7% of the rest energy of the fuel. That is the ceiling. It is not a matter of engineering. It is set by where the nucleons end up on the binding curve. Fuse all the way up to iron, and you can reach about 0.9%, and there it stops. Everything a star will ever do, across billions of years, is done with under 1% of what its own equation nominally offers. Hold on to that number. It becomes important when we get to the arithmetic of weapons. There is one more detail I love here. About 2% of that 26.7 million electron volts per helium nucleus leaves as neutrinos, and neutrinos barely interact with anything at all. They do not bounce around inside the sun the way photons do. They go straight out, at essentially the speed of light, and they arrive here about 8 minutes later. Around 65,000 million of them are passing through every square centimeter of you, right now, in the dark, and have been every second of your life. The photons take a very different route. A photon born in the solar core does not fly out. It is absorbed and re-emitted so many times in a random walk through the dense interior that estimates for the journey to the surface range from about 10,000 to 170,000 years, depending on how you model the opacity. The sunlight that warmed your face this afternoon began as a nuclear rearrangement in the core before there were cities. So the sun has given us the first hard case, and the accounting held. Every nucleon accounted for. Nothing converted, just a very large hillside, settling. But everything so far has still run one way. Energy came out, so the sun got lighter, the same direction as the cooling coffee, just at a scale that beggars the imagination. Now we turn around and go the other way, because there is a case where nothing comes out at all, where nothing escapes, where you can seal the box as tightly as you like, and the object still weighs less than the pieces you built it from. Here is the fact I left on the table at the very beginning, and now we can take it apart properly. A hydrogen atom weighs less than the proton and the electron inside it. Let me give you the numbers, because the numbers are what make it undeniable. A proton, on its own, has a rest energy of about 938.27 million electron volts. An electron, on its own, has a rest energy of about 0.511 million electron volts. Add them, 938.78 million electron volts. Now weigh a hydrogen atom in its ground state. It comes out lower than that, by 13.6 electron volts. 13.6 electron volts. That is the ionization energy of hydrogen, the amount of energy you have to put in to tear the electron away from the proton and get your two separate particles back. And the atom is lighter than its parts by exactly that amount, divided by the speed of light squared. The fraction is about 1 part in 70 million. Small, but the size is not what matters here. The sign is what matters. Every single case we have looked at so far has been a plus. Energy in, mass up. The wound watch, the boiled water, the charged phone, the box of trapped light. And a person can absorb all of that and still tell themselves a version of the old story. Fine, energy is a kind of stuff too. And when you add it, you add mass. And mass is still counting how much is present. This one is a minus. Nothing was taken out of the hydrogen atom. There is no third particle that escaped, because there was never a third particle. Count them afterwards. 1 proton, 1 electron. Exactly what went in, and the total is smaller than it was. So sit with this for a moment, because I think it is the moment the ordinary idea of mass stops working and cannot be repaired. Everything you were ever taught about weight assumed that weight is a count. More stuff, more weight. Take some away, weigh less. Every instinct you have about this, every time you have picked up a bag and known immediately whether it was full, rests on that assumption. And here is an object, the simplest object in all of chemistry, 1 proton and 1 electron and nothing else, where every part is present and the total has gone down. That cannot be a count. Whatever the number on a scale is, it is not a tally of what is there, because if it were, this could not happen, and it happens in every atom in the universe. The mechanism is beautiful, and once you have it, it never leaves you. Potential energy can be negative. Set the electric potential energy of a proton and an electron to 0 when they are infinitely far apart. That is a choice, but it is the natural one, because at infinite distance they do not feel each other at all. Now let them come together. They attract, because opposite charges attract, so bringing them closer is downhill, and downhill from 0 is below 0. So the electron in a hydrogen atom sits at negative electric potential energy. That is not a bookkeeping trick. It is a statement that you would have to put energy in to get back to where you started. The electron also has kinetic energy, because it is not sitting still. Kinetic energy is always positive, so the total is a fight between a positive number and a negative one. And there is a theorem, the virial theorem, which tells you exactly how that fight comes out for an inverse square force, like electricity or gravity. The average potential energy is minus twice the average kinetic energy, not approximately. Exactly, for a stable bound system. Run it for hydrogen. The kinetic energy averages plus 13.6 electron volts. The potential energy averages minus 27.2. Add them, minus 13.6. Negative. The bound system's internal energy is less than 0, taking the separated particles as the 0 point. And by the rule we have been building all night. Internal energy shows up as mass. The atom weighs less. That is the whole explanation. Nothing exotic. A theorem about attractive forces, and the rule that internal energy has weight. And now, watch it spread, because it does not stop at hydrogen. Every neutral atom on the periodic table weighs less than the sum of its protons, neutrons, and electrons. A carbon atom, defined for historical reasons to weigh exactly 12 units, is made of 6 protons, 6 neutrons, and 6 electrons that sum to about 12.099. The deficit is about 0.8%, and most of that is nuclear, which we will get to, but the principle is identical. Every molecule weighs less than the atoms bonded into it. Take an oxygen molecule, two oxygen atoms sharing a double bond. Breaking that bond costs about 498 kilojoules per mole, which is about 5.2 electron volts per molecule. So the molecule is lighter than two separate oxygen atoms by about 1.7 parts in 10,000 million. Every chemical reaction that releases energy leaves products lighter than the reactants. Burn hydrogen in oxygen to make water, and you get about 286 kilojoules per mole out, which means that 18 grams of water, a small glass, about a tablespoon, weighs roughly 3 nanograms less than the hydrogen and oxygen it was made from. Think about what that means for every fire that has ever burned, every campfire, every candle, every engine, every forest that ever went up. In each one, the ash and smoke and carbon dioxide that came out weigh very slightly less than the fuel and the air that went in. Not because atoms were destroyed. Every carbon atom in the wood is still out there in the atmosphere somewhere. Because the atoms ended up in tighter arrangements, and the difference left as light and heat. Nobody has ever weighed this. The effect for a chemical reaction is around 1 part in 10,000 million, which is at the absolute edge of what the finest mass metrology can do with kilogram artifacts and hopelessly out of reach for a bonfire. But it is there in every fire that has ever burned, and it is not a rounding error. It is the reason the fire is warm. There is a small companion to hydrogen that makes the rule feel almost tidy. Positronium is an electron bound to a positron, its own antiparticle, orbiting each other with no proton involved at all. Its binding energy is 6.8 electron volts, exactly half hydrogen's, and for a completely predictable reason. The two partners have equal mass, so they orbit a shared center instead of one of them sitting nearly still, and the arithmetic halves. The rule is not a special property of protons, it is the geometry of attraction. And it is worth noticing what the virial theorem is really telling you, because it generalizes. For any force that falls off as an inverse square, electricity, gravity, either one, twice the kinetic energy equals the size of the potential energy, and the total lands negative. That is why the same sentence describes an electron around a proton, a moon around a planet, and a star around a galaxy. The scales differ by 40 orders of magnitude. The bookkeeping does not change at all. Now scale it all the way up, because gravity does exactly the same thing. The Earth is bound together by its own gravity. Every kilogram of rock in it is attracted to every other kilogram, and assembling the planet from a diffuse cloud of dust was downhill all the way. The energy released by that infall is enormous. The Earth's gravitational binding energy is about 224,000 million joules. Divide by the speed of light squared, and you find that the Earth weighs about 2.5 trillion tons less than the dust and rock it formed from. 2.5 trillion tons, gone from the ledger, and not one grain of that dust was destroyed. It is all still here, under your feet. The planet is simply bound, and bound things weigh less. At the extreme end, this becomes impossible to ignore. Take a neutron star. To build one, you collapse the core of a massive star until the whole thing is essentially one enormous nucleus, and the binding is so tight that a typical neutron star ends up with a gravitational mass of about 1.4 times the Sun, having been assembled from something like 1.6 or 1.7 suns worth of neutrons. Between 10 and 20% of everything that went in is missing from the final weight. Every neutron is still there. Count them, and the number is unchanged. What left, in a few seconds during the collapse, was a flood of neutrinos and light carrying away the binding energy, and the object left behind weighs a fifth less than its own contents. So here is where we now stand, and I want to state it precisely, without stating the conclusion. because we have not earned that yet. Put energy into a system and it weighs more. Bind a system together and it weighs less. And in both cases, the inventory of particles is completely unchanged. Two rules pointing in opposite directions, and neither of them is about how much stuff is present. Let us stop for a moment and put the pieces we have on the table together, because the next stretch goes somewhere much stranger, and I want you carrying all of it. Let us step back and put the pieces together, because we are about halfway through, and the next stretch is going to move quickly. We started with a machine in a bathroom, and a question nobody had ever answered. What is the number on a scale actually measuring? We went back to a 3-page paper written by a patent clerk in the autumn of 1905, and found that the equation everyone can recite was originally written the other way round, mass on the left, energy on the right, and that Einstein's own closing line called mass a measure of energy content. A measure, not a container, not a store, a reading. Then we went looking for consequences, and found them everywhere. We found that a wound-up wristwatch weighs more than a stopped one, by about 10 femtograms, because the spring is strained, and the gears are moving, and the case is very slightly warm. We found that a fresh battery weighs more than a flat one, a hot kettle more than a cold one, a full phone more than an empty one, a spinning flywheel more than a still one. In every case, the inventory of atoms was identical, and the number on the scale was different. We found the reason nobody ever noticed: the exchange rate, 90,000 million joules to the kilogram. Everything a human being does, at the scale a human being does it, corresponds to mass differences in the nanograms. Then we sealed a torch inside a mirrored box and found that a system full of massless light has mass, and more disturbingly, that the same two photons give the system mass or give it none, depending only on which way they are pointing, which told us that mass does not add. Mass is not a component of anything. It is the length of an arrow, and lengths do not add when arrows do. Then we went to the sun and watched 4.25 million tons leave every second, and found that not a single nucleon was destroyed to produce it. 4 protons went in, 4 nucleons came out, and what left was the difference between a loose arrangement and a tight one, a landslide. The rocks are all still at the bottom of the hill, and then the direction reversed. A hydrogen atom weighs less than the proton and electron inside it, by 13.6 electron volts, because potential energy in a bound system is negative, and the virial theorem says it wins. And that is not a hydrogen fact. It is every atom, every molecule, every fire that has ever burned, the Earth by 2.5 trillion tons, and a neutron star by 1/5 of itself. So here is the whole picture as it stands. Put energy in, the number goes up. Bind things together, the number goes down. In both directions, nothing was created and nothing was destroyed. And in both directions, the number on the scale has nothing to do with how much material is present. There is one more thing worth restating before we move, because it is the piece that does the most work later, and it is the easiest to lose. The mass of a system is not the sum of the masses of its parts. It never was. It depends on the arrangement of those parts and on how they are moving inside the whole, and both of those can push the total up or drag it down. A sealed box whose contents you know completely, atom by atom, is a box whose weight you cannot predict. Not until somebody tells you how the contents are arranged and how fast they are jiggling. That single sentence explains the watch, the kettle, the box of light, the hydrogen atom, the sun, and the earth. 6 completely different situations, 1 rule, and it is going to explain everything that follows too. That is a lot to have established, and I want to be honest that at this point you could still, if you wanted, hold on to a modified version of the old picture. You could say, fine, mass counts stuff plus energy. Both contribute. That is a real position, and it survives everything we have said so far. The rest of tonight is going to take that position apart. And it starts here, with a simple question of scale. Everything we have measured in the chemical world sits at around 1 part in 10,000 million. That is what a chemical bond is worth. A few electron volts against a few thousand million electron volts of rest energy. It is why the effect is invisible in a kitchen. But a chemical bond is the weakest kind of binding there is. It is electrons rearranging in the outer suburbs of an atom, held by electric forces across distances of 1/10 of a nanometer. Go inside the nucleus, and the numbers change by a factor of about 1,000,000. Nuclear binding energies are measured in millions of electron volts per particle, not single electron volts. The force is 100 times stronger than electromagnetism, and it operates across distances 100,000 times smaller. And if the mass deficit of a chemical bond is 1 part in 10,000 million, then the mass deficit of a nuclear bond is going to be something around 1 part in 1,000. 1 part in 1,000 is not invisible. 1 part in 1,000 is measurable, with equipment that existed in the 1930s. 1 part in 1,000 is the difference between a curiosity and a technology. It is the point at which a mass deficit stops being something you argue about in a lecture hall and becomes something you can put on a balance and read off with your own eyes. And that factor of 1,000,000 between chemical and nuclear binding is, when you think about it, the entire reason the 20th century looks the way it does. It is why a kilogram of coal and a kilogram of uranium are separated by 6 orders of magnitude in what they can do. It is why the same principle that makes a bonfire imperceptibly lighter makes a city disappear. The physics did not change between those 2 cases. Only the depth of the hillside did. And here is what I want you to be watching for as we go in there. Everything we say about nuclei is going to be the same physics we have already established. The same landslide, the same binding, the same rule. But this is the domain where the wrong sentence took hold. This is where matter converts to energy was born and where it still lives. Nuclear reactors, nuclear weapons, the place where physics and history collided in front of the whole world, and where the language got fixed for a century. It is worth being fair to the people who fixed that language, by the way. They were not careless. In the 1940s, the men and women explaining this to the public were describing something genuinely without precedent, in a hurry, to an audience with no framework for it, and matter was converted into energy, is a sentence that gets you the right number and the right sense of scale in 9 words. As shorthand for the arithmetic, it is perfectly serviceable. It is only wrong about what physically happened, and for most purposes, for most of the last 80 years, nobody needed to care about that difference. We are going to care about it, because the difference is the whole subject. So we are going to go there and check the books, item by item, and see whether a single particle was ever destroyed. And I will tell you now, it was not. Not once. Not in any reactor. Not in any weapon. Not anywhere on Earth, or in any star in the sky. But you should not take my word for it. So let us count. Start with the simplest nucleus that has more than one piece in it. A deuteron is a proton and a neutron stuck together. Heavy hydrogen, the thing that makes heavy water heavy. Take a free proton at about 938.27 million electron volts and a free neutron at about 939.57 and add them. You get about 1877.8. Now weigh an actual deuteron, 1875.6. The deficit is 2.22 million electron volts. That is the binding energy of the deuteron. And as a fraction, it is about 1 part in 850, a bit over 1/10 of 1%. Compare that to hydrogen's 13.6 electron volts, 1 part in 70 million. Same object, more or less. A proton with one other particle attached. And the deficit is about 5 orders of magnitude larger, because the strong force is a completely different animal from electricity. Go one step further, to helium. 2 protons and 2 neutrons, free, sum to about 3,755.7 million electron volts. The bound helium nucleus, the alpha particle, comes in at about 3,727.4. The deficit is 28.3 million electron volts, about 0.75%. There it is. That is the number that runs the sun. That is the 0.7% I asked you to hold on to, and now you can see where it comes from. It is simply how much lower 4 bound nucleons sit than 4 loose ones. Nothing more mystical than that. And now, the curve. If you take every nucleus on the chart and plot binding energy per nucleon against how many nucleons it has, you get one of the most important shapes in all of science. It rises steeply from hydrogen through helium and carbon and oxygen, keeps climbing more gently, and reaches a broad maximum somewhere around iron and nickel, a little under 9 million electron volts per nucleon. And then it turns over and comes back down through the heavy elements to uranium. There is a lovely piece of pedantry here that is worth having. Everyone says iron 56 is the peak. It very nearly is, but the actual maximum binding energy per nucleon belongs to nickel 62, at about 8.7945 million electron volts, followed by iron 58, and then iron 56. Iron 56 does hold a different record. It has the lowest mass per nucleon, because neutrons are slightly heavier than protons, and iron 56 has a favorable mix. So both textbook claims are true, and they are about different quantities. It is a small thing, but it tells you something about how carefully this curve has been measured. Here is what the shape means. Everything wants to get to the middle. Light nuclei get more tightly bound by fusing together and climbing the left slope. Heavy nuclei get more tightly bound by splitting apart and climbing the right slope. Both roads run downhill in energy, and both roads run uphill in binding, and they meet at nickel and iron. Which is why fusion and fission both release energy while sitting at opposite ends of the periodic table, and why the 2 most powerful energy technologies humanity has ever built are, in a strict sense, doing opposite things for the same reason. It is also why nothing past iron can ever be a fuel. Once you are at the bottom of the valley, there is no more downhill. Every element heavier than iron in your body, the zinc, the copper, the iodine, the iron in your blood, is right at the floor, took energy to make rather than releasing it, which is why those elements are forged in supernovae and neutron star collisions instead of in the calm middle age of a star. Radioactive decay, incidentally, is the same accounting on a much slower clock. When a radium nucleus spits out an alpha particle and becomes radon, the radon and the alpha particle together weigh less than the radium did, by about 4.87 million electron volts worth. That is where the energy of the alpha comes from. It is also, as it happens, exactly the effect Einstein pointed at in the last line of his 3-page paper when he suggested radium salts might be the place to look. He had no idea what a nucleus was. Nobody did in 1905. The nucleus would not be discovered for another 6 years, and he still put his finger on the right substance. Now let us go to the case that everyone reaches for, and let us do the arithmetic honestly. Fission of a uranium-235 nucleus releases about 200 million electron volts. The rest energy of that nucleus is about 219,000 million electron volts. So the released fraction is around 0.09%, about 8 times less efficient than fusion, in these terms, which surprises people. Take the device dropped on Hiroshima. Its yield was about 15,000 tons of high explosive equivalent, which is roughly 63 million joules. Divide by the speed of light squared, 0.7 grams. The products of that explosion weighed about 0.7 of a gram less than the device had weighed before it went off. Less than a gram. Less than a small paperclip. less than a single sheet of paper. That figure is genuinely difficult to hold in the mind, and it is usually presented as though it were the most shocking thing about the number. Look how little matter is needed. But that is exactly the wrong reading, and I want to be careful here. The bomb contained about 64 kilograms of uranium. Of that, perhaps 1 kilogram actually underwent fission, and in that 1 kilogram there were roughly 2.5 million nucleons. Every single one of them was still there afterwards. Not most of them, all of them, every proton, every neutron that went into that reaction came out the other side, sitting inside a fission fragment. Barium, krypton, cesium, strontium, the whole ugly inventory of fallout that people were still measuring in soil and bone for decades. The number of nucleons before and the number after are identical. Nothing was converted. What changed is that those nucleons were arranged as uranium, high on the right slope of the curve, loosely held, and afterwards they were arranged as medium-weight fragments, much lower down, much more tightly held. The difference in binding, summed over a kilogram of nuclei, is about 63 million joules, and it came out as light, heat, neutrons and gamma rays in less than a microsecond. It is the landslide again. The rocks are all at the bottom of the hill, every one of them. Nobody destroyed a rock, and the village is gone because of how far they fell. I find this genuinely important, and not just as a matter of accuracy. The phrase, matter was converted into energy, carries an implication that a specific quantity of substance stopped existing, that a small pile of uranium simply vanished from the universe, and the vanishing is what did the damage. That picture makes nuclear physics sound like alchemy or magic. It makes the energy sound like it came from nowhere. It did not come from nowhere. It came from the difference between two arrangements of the same particles, and the reason the number is so appalling is not that matter is precious, but that the exchange rate is 90,000 million joules to the kilogram. 7/10 of a gram is a catastrophic amount of energy for exactly the same reason that a fresh battery is only 1/10 of a nanogram heavier than a dead one. It is the same constant. Read in the other direction. There is a detail about fission that makes the arrangement picture almost tangible. The fragments a uranium nucleus splits into are neutron-rich. They inherit uranium's ratio of neutrons to protons, which is far too high for a medium-weight nucleus. So they keep adjusting for a long time afterwards, shedding beta particles, working their way toward a comfortable arrangement. That is why spent fuel stays hot for years, and why about 7% of a reactor's thermal output at the moment of shutdown is decay heat that cannot be switched off. A reactor is not a fire you can put out. It is a hillside that is still settling. The rest of the ladder falls into place from here. The Tsar Bomba, the largest device ever detonated, in 1961, yielded about 50 megatons, a mass difference of about 2.3 kilograms. A gigawatt nuclear power station running for a year corresponds to about 1 kilogram. Every reactor on Earth, all of them together, runs on a few tons a year in these terms. And the first person to actually check any of this did it in 1932, in Cambridge, with a machine built on a bench. Cockcroft and Walton accelerated protons into lithium and split it into 2 alpha particles, measured the energy of those alphas, compared it against the known mass difference between the ingredients and the products, and found they matched. That was the first direct confirmation in a nuclear reaction that the relation Einstein had scribbled onto 3 pages in 1905 was actually how the world works. They shared a Nobel Prize for it 19 years later. So the nuclear case holds too. Every nucleon accounted for, nothing converted, just a much steeper hillside than the ones we have been walking on. But we are still one level too shallow, and this is where the ground genuinely gives way, because we have been treating protons and neutrons as though they were the solid pieces, the actual rocks, the things the hillside is made of. They are not. And what they are instead is the strangest fact in this entire subject. A proton has a mass of about 938 million electron volts in the units particle physicists use. It is made of 3 quarks, 2 up quarks and 1 down quark. That is the recipe, and it has been the recipe since the 1960s. So let us add them up. The up quark has a mass of about 2.16 million electron volts. The down quark, about 4.67. 2 ups and a down, about 8.99. 9 against 938. The quarks account for roughly 1% of the proton's mass. I want to give that a moment, because when I first properly understood it, it took a while to land. If you take a proton apart and lay out everything inside it, everything with a name, everything on the ingredient list, you have accounted for 1% of the weight. 99% of a proton is not the mass of anything inside it. So what is it? Let me take you in there. Shrink down, past the scale of a room, past a grain of dust, past a molecule. You arrive at an atom, and the first thing you notice is that it is almost entirely empty. A nucleus like a marble in the middle of a cathedral, and out at the walls a haze of electron probability that is not really anywhere in particular. Keep going. Into the nucleus. Now you are among the protons and neutrons, packed together, and this is where your intuition tells you the actual substance lives. This is where the stuff is. This is where the mass is. Go into a single proton, and it should be, by that logic, the most solid place in the universe. It is not solid at all. What you find is a storm. The gluon field, the thing that carries the strong force, fills the whole volume, and unlike an electric field, it does not sit quietly, because gluons carry the charge they respond to, and so they act on each other. The field is knotted and violent and everywhere. Quark-antiquark pairs are flickering into existence and out again constantly, borrowed from nothing and returned before anyone notices. And through all of this, the 3 quarks you came looking for are moving at very nearly the speed of light, unable to leave, unable to slow down. There is no flaw in here. There is no small, hard thing at the middle. You look for the substance, and you find motion and field, and when you ask which part of it is the mass, the answer is all of it. The mass is the storm. There is nothing else here to be the mass. The 3 quarks you were counting weigh, between them, 1% of what this thing weighs. The other 99% is the energy of the field and the energy of the motion, and if you could somehow switch off the strong force for a moment, that 99% would simply not be there. That is the mechanism, and it deserves a proper explanation because it is the deepest example of the rule we have been building all night. Quantum chromodynamics, the theory of the strong force, has a property that electromagnetism does not. The particles that carry the electromagnetic force, photons, are electrically neutral, so they pass through each other without interacting. The particles that carry the strong force, gluons, carry the strong charge themselves, so gluons pull on gluons. The consequence is confinement. An electric field between 2 charges falls off with distance, so you can always pull 2 charges apart if you push hard enough. A strong field between 2 quarks does not fall off. It forms into a narrow tube, and pulling the quarks apart does not weaken it. It just makes a longer tube, storing more and more energy, until eventually the field has enough energy in it to make a new quark-antiquark pair from scratch and snap into 2 shorter tubes. That is why nobody has ever seen a free quark. Not because they are hidden, but because pulling one out costs more energy than it takes to make new ones. And it means that the inside of a proton is a permanently high-energy place. The quarks are trapped in a volume about a femtometer across, 1,000th of a millionth of a millionth of a meter, and the uncertainty principle alone says that anything confined that tightly must be moving very fast indeed. Add the field energy of the confining tubes, and you have your 99%. I should correct something I said a moment ago, because I said 3 quarks, and that is only true in a particular accounting sense. At any given instant, a proton contains far more than 3 quarks. It contains a sea of quark-antiquark pairs constantly appearing and vanishing, and an indeterminate crowd of gluons. When physicists say a proton is made of 2 up quarks and a down quark, what they mean is that if you count all the ups and subtract all the anti-ups and do the same for downs, that is the net excess you are left with. 3 is a balance, not an inventory. The actual population inside a proton at any moment is not a fixed number and cannot be. There is a related puzzle that has been open for 40 years, and it makes the same point from another angle. A proton has a definite spin, and the natural assumption was that the spins of the 3 quarks add up to it. In the 1980s, experiments at CERN, scattering polarized muons off polarized protons, found that the quark spins account for only about 30% of it. The rest is carried by gluon spin and by the orbital motion of everything inside. Even the proton's angular momentum is mostly not the property of the particles you can name. Now, notice something. In the hydrogen atom, binding made the system lighter because electric potential energy went negative. In the proton, the binding makes the system 100 times heavier. Same rule, opposite outcome. And the reason is simply that the energy in the confining field is positive and enormous, while the negative contributions do not come close to matching it. The rule was never, binding makes things lighter. The rule was always, add up the total internal energy, whatever its sign, and that is your mass. And this is not physicists waving their hands. This is calculated. Lattice quantum chromodynamics simulates the quantum field on a discrete grid of spacetime points and lets a supercomputer grind through the possibilities, and in 2008, a collaboration based in Budapest, Marseille and Wuppertal published a calculation in the journal Science that produced the masses of the proton, the neutron, and the other light particles from first principles, using only the quark masses and the strength of the strong force as inputs, agreeing with experiment to within a few percent. The mass of the proton is not a measured constant that physics has to accept. It is a number physics can now compute, from a theory in which almost none of it is the mass of anything. The same group went further in 2015 and did something I find quietly astonishing. A neutron is slightly heavier than a proton, 939.57 against 938.27, a difference of about 1.29 million electron volts, which is barely 1 part in 700. That tiny gap is the result of 2 effects fighting each other. The down quark is heavier than the up quark, which pushes the neutron up, while the proton's electric charge gives it extra electromagnetic self-energy, which pushes the proton up. The lattice calculation resolved the difference from first principles and got it right. And that 1.29 million electron volts is one of the most consequential small numbers in existence. Because the neutron is heavier, a free neutron is unstable. It decays in about 15 minutes into a proton, an electron, and an antineutrino, running downhill exactly as everything else in this story does. And because the proton is the lighter one, it has nowhere to fall to, and so it appears to be stable forever, which means hydrogen exists, which means water exists, and stars have fuel, and chemistry has a lightest element to build from. Flip that gap the other way, and there is no universe recognizable as this one. There is a stranger layer underneath even that. The theory's inputs include a dimensionless number, a coupling strength, with no units at all. Through a process called dimensional transmutation, that pure number generates a scale around 200 million electron volts, and that scale is where the proton's mass comes from. Almost all the mass of ordinary matter is produced by a theory whose ingredients contain essentially no mass. Now let us bring this home, because so far it is a fact about a particle and it should be a fact about you. You are made of atoms. The atoms are made of electrons and nuclei. The nuclei are made of protons and neutrons, and 99% of the mass of every proton and every neutron in your body is field energy and motion. So take a body of 70 kilograms. Roughly 69 of those kilograms are not substance in any sense you would recognize. They are the energy of the strong field, tangled up inside a few times 10 to the 28th nucleons, holding itself together. Your bones, your blood, the weight of your own arm resting on the blanket, the pressure of your body against the mattress right now. Almost none of it is stuff. It is a self-sustaining pattern of energy, with no more thingness than a standing wave on a rope. And you have been carrying this around your entire life. You have stood on scales and read the number, and thought it was telling you how much of you there was. 69 kilograms of that number was the strong nuclear force, holding on. That is the 99%. There is still 1% left over, the actual masses of the quarks themselves, and the mass of the electron. You might reasonably hope that down there, at last, we finally reach something solid, some irreducible grain of substance that everything else is built on. We do not, and the reason is the last piece of this puzzle. So we have 1% left, the quarks themselves, and the electron. These are, as far as anyone can tell, genuinely elementary, not made of smaller things. Points, with no internal structure and no interior to contain anything. If there is a place in this universe where mass is finally just mass, a brute quantity of substance with no further explanation, this is where it has to be, and it is not there either. In the standard model, an electron and a quark have mass because of an interaction with a field that fills all of space. It is called the Higgs field, and its distinguishing feature is that its value in empty space is not zero. Every other field we know settles to zero when nothing is happening. This one does not. It sits at a constant non-zero value everywhere, in every cubic centimeter of your room, in the gaps between galaxies, in the middle of the sun. Every fundamental particle couples to that field with a certain strength, a number called its Yukawa coupling, and the mass it exhibits is that coupling multiplied by the field's background value, which is about 246,000 million electron volts. The idea was proposed in 1964, independently and within a few months of each other, by three separate groups: Robert Brout and François Englert in Brussels, Peter Higgs in Edinburgh, and Gerald Guralnick, Carl Hagen, and Tom Kibble in London. Only Higgs's paper explicitly mentioned that the mechanism implied a new particle, which is a large part of why his name is on it. The existence of this field was confirmed on the 4th of July 2012, when the ATLAS and CMS experiments at CERN announced that they had found the Higgs boson at about 125,000 million electron volts. The boson is the ripple in the field, the evidence that the field is a real, disturbable thing, rather than a bookkeeping fiction. Now, you have probably heard the Higgs field explained with treacle. Particles move through it, the story goes, and it slows them down, and that resistance is what we call mass. Sometimes it is a celebrity moving through a crowded room. That picture is not just simplified, it is wrong in a specific and instructive way. A drag force slows things down. If the Higgs field genuinely dragged on particles, everything in the universe would gradually come to rest. There would be a preferred frame of reference in which things stopped, and special relativity would be finished. None of that happens. The Higgs field does not resist motion. An electron in deep space, coasts forever. What actually happens is subtler and much more interesting. Without the interaction, a particle's energy would be exactly proportional to its momentum, which is the condition for traveling at the speed of light. That is what a photon does. The coupling to the Higgs field changes that relationship. It puts a floor under the energy, so that even at zero momentum, there is energy left over. That leftover energy, at zero momentum, is what we call rest mass. So even here, at the supposed bottom of the ladder, mass is not a substance handed to a particle. It is the residual energy of an interaction that never switches off. And there is more, because electrons and quarks also interact with the fields they themselves produce. An electron is surrounded by its own electromagnetic field, and that field has energy, and that energy contributes to what we measure as the electron's mass. A quark is surrounded by its own gluon field, and the same applies. In classical physics, this was a disaster. Calculate the self-energy of a point charge, and you get infinity, which is one of the reasons the classical electron was such an embarrassment. Quantum field theory deals with it through renormalization, which in effect says, we cannot separate the bare particle from its own field, so let us not try, and let us define the mass as the thing we actually measure. That is worth hearing plainly. In the best theory we have, the bare mass of an electron, the mass it would have with all its interactions switched off, is not an observable quantity at all. It cannot be measured even in principle. What can be measured is the electron plus everything it is doing. The Higgs field does one more thing that is worth mentioning, because it shows up in the sky every day. It also gives mass to the W and Z bosons, the carriers of the weak nuclear force, at about 80 and 91,000 million electron volts respectively. Those are enormous, roughly 90 times a proton, and a force whose carrier is heavy is a force with a very short reach and a very low probability of acting, which is precisely why the weak interaction is weak. That has a consequence you can see with your own eyes. The first step of the proton-proton chain in the Sun's core requires two protons to bump into each other, and, in the instant of contact, for one of them to undergo a weak force conversion into a neutron. That is so improbable that a given proton in the core waits, on average, something like 9,000 million years for it to happen, which is why the Sun burns slowly instead of detonating, and why there has been time for anything to happen on this planet at all. The heaviness of a force carrier, itself an interaction energy with a field, is the reason the sky is a steady lamp instead of a flash. So every layer we have opened tonight has returned the same answer. Molecules are lighter than their atoms because of interaction energy. Atoms are lighter than their particles because of interaction energy. Protons are 100 times heavier than their quarks because of interaction energy. And the quarks and electrons have mass because of interaction energy with a field that fills space. There is no bottom. The regress does not end in substance. It ends in interactions, all the way down, and then it stops being a regress because there is nothing left to be made of. Now, I want to be careful and honest about what is not explained here, because it matters. The Higgs mechanism explains why particles have mass. It does not explain why they have the particular masses they have. Each fermion's coupling to the Higgs field is a number that has to be measured and put into the theory by hand. The electron's coupling is about 3 millionths. The top quark's is about 1. That is a spread of nearly 6 orders of magnitude across a handful of particles, with no pattern anyone has been able to derive. Nobody knows why. It is called the flavor hierarchy problem, and it is one of the largest open questions in particle physics. One of those places where the theory works perfectly and explains nothing about its own inputs. And there is at least one mass the mechanism does not cover at all. Neutrinos have mass. We know this because they change type as they travel, and that oscillation is impossible for a massless particle. But their masses are so tiny, below about half an electron volt from the best direct measurements, that the ordinary Higgs coupling does not plausibly account for them. Something else is going on there, and nobody yet knows what. There is one more consequence worth sitting with. Because 99% of your mass comes from the strong force and only 1% from the Higgs field, You could imagine switching the Higgs field off and ask what would survive, and the answer is that protons and neutrons would still have almost exactly the mass they have now. The mass of ordinary matter would barely notice. But the electron would become massless, and a massless electron cannot be bound to a nucleus, and so there would be no atoms, no chemistry, no molecules, no solids, no liquids, no you. The 1% that barely registers on the scale is the 1% that makes matter into things. That is where the search for solid substance ends. There is nowhere left to look, except that a listener with any fight left in them still has one card, and it is the strongest card there is, because none of what we have discussed involves particles actually ceasing to exist. Bound, unbound, rearranged, yes, but every proton stayed a proton. There is a process where that is not true, where a particle genuinely stops existing, and if mass is ever going to turn into energy anywhere in this universe, it will be there. An electron meets a positron. Both of them cease to exist. 2 gamma rays fly out. This is annihilation, and it is the strongest objection anyone can raise against everything I have said tonight. Every other case involved rearrangement, particles that stayed particles, moving between arrangements. This one does not. 2 objects with mass go in. 2 objects with no mass at all come out. The electron is gone. It is not hiding somewhere in a fragment. It does not exist anymore. If matter ever turns into energy, it turns into energy here. So let us do the books. Put the 2 particles at rest, facing each other, and let them come together. Let me put you next to it. You are watching a scale. On it sits a sealed container, and inside that container are 2 particles, 1 electron and 1 positron, drifting slowly toward each other. They are as close to identical as 2 things can be. Same mass, same spin, opposite charge. Each has a rest energy of 511,000 electron volts. They touch. There is no explosion, no fragment, no debris. They simply stop being. In their place, 2 gamma rays leave in exactly opposite directions, each carrying 511,000 electron volts, moving at the speed of light. Total, complete destruction, the most complete that the laws of physics permit anywhere in the universe. 2 particles with mass have become 2 particles with none, and the needle on the scale does not move. Not by a part in a million, not at all. Provided nothing escapes the container, the reading before and the reading after are identical. Let us see why. Before, 2 particles at rest, each with rest energy of 511,000 electron volts. No net momentum. The mass of that system is 1,022,000 electron volts worth. Straightforward. After, 2 photons, each of 511,000 electron volts, traveling in exactly opposite directions. Each photon individually has 0 mass. But we already know what happens when you compute the mass of a system of 2 photons flying apart. We did it back in the mirrored box. Their energies add, their momenta, being opposite, cancel exactly, and the mass of the system comes out to twice the energy of 1 photon divided by the speed of light squared. 1,022,000 electron volts worth. The same number. Not approximately the same. Exactly the same. Nothing about the system's mass changed. 2 particles that individually had mass were replaced by 2 particles that individually have none, and the mass of the system was untouched, because mass never added in the first place. What actually changed is the form the energy takes. Rest energy became radiant energy. But rest energy was never a different substance from radiant energy. It was always energy. It was energy sitting in a configuration that happened to have no net momentum, which is exactly what being a particle at rest means. The particles are gone, their electric charges cancelled, their lepton numbers balanced, and none of those things is mass. So even here, in the most complete annihilation available anywhere, nothing was converted. The books balanced perfectly, to the last electron volt, and the scale did not move. It is worth saying that this is also, incidentally, the reason antimatter is not an energy source. It is the only fully efficient process in nature, 100%, against fission's 0.09%, and fusion's 0.7. But you cannot mine it. Every anti-proton humanity has ever made was manufactured in an accelerator at an energy cost something like 1,000 million times greater than what its annihilation would return. Total global production, across all of history, is measured in nanograms. The most efficient reaction in the universe is, as a practical matter, the most expensive. And this is not a thought experiment sitting in a textbook. It happens inside human beings, every day, in hospitals, on purpose. A positron emission tomography scan works like this. A patient is given a sugar molecule with a radioactive fluorine atom attached. That fluorine decays, emitting a positron. The positron travels a millimeter or two through tissue, slowing as it goes, until it meets one of the countless electrons around it. They annihilate. Two gamma rays leave in exactly opposite directions, pass out through the body, and are caught by a ring of detectors that know they must have come from somewhere on the straight line between them. Millions of those lines, crossed against each other, become an image of where the sugar went. Every single one of those events is the annihilation we just described, and the geometry that makes the scan possible, the exactly opposite directions, is the same geometry that makes the mass of the system come out unchanged. The most widely used medical application of antimatter on Earth is running, right now, on the arithmetic of this part. Now let me tell you why the conversion idea has such a grip, because I think this is genuinely the psychological heart of it. People expect conserved quantities to be substances. If a thing is never created and never destroyed, it feels like it must be made of something. So, energy is conserved, momentum is conserved, electric charge is conserved, baryon number and lepton number are conserved. Mass is not on that list. It never was. Mass is not a conserved quantity, and the moment you notice that, the whole picture reorganizes. It is not a substance that gets destroyed in annihilation. It is not a substance at all. It is a derived quantity, something you calculate from other things. Specifically, this, the mass of anything, a particle, a box, a star, a system of two photons, is defined by taking its total energy, squaring it, subtracting its momentum times the speed of light, squared, and taking the square root. That is the definition. Everything tonight follows from it. And there is a way of seeing that definition which, once you have it, makes the whole subject feel obvious rather than paradoxical. Energy and momentum are not two separate things. They are components of a single four-dimensional object, an arrow in space-time. Different observers, moving differently, disagree about the components. Someone running past you sees more momentum and more energy in the same object. Someone traveling alongside it sees no momentum at all. They all disagree about the numbers, but they all agree about the arrow's length. That length is the mass. And now consider what a strange thing it would be to say that you had converted an arrow into its own length. The length is not a part of the arrow. It is not a payload the arrow carries. It is not a substance that could be extracted, released, or destroyed. It is a property the arrow has, a number describing it. You cannot convert an arrow into its length, and you cannot convert mass into energy, for precisely the same reason. The relationship is not a transaction, it is a description. And notice what that explains, retroactively, about everything tonight. Two photons flying apart have long arrows pointing in opposite directions, and adding two opposite arrows leaves you with a long one, so the system has mass. Two photons flying the same way have arrows that reinforce, and the sum lies exactly along the direction where the length is 0, so the system has none. A wound watch has slightly more energy and no more momentum, so its arrow is slightly longer. A bound hydrogen atom has slightly less energy than its separated parts, so its arrow is slightly shorter. A proton is a knot of arrows pointing in all directions at once, whose energies add and whose momenta cancel, which is exactly the recipe for a long total arrow, and that is the 99%. Every single case tonight is the same picture. 6 months ago, I would have said these were 6 different phenomena. They are one, seen from 6 angles. This process runs perfectly well in reverse too, which is another thing a conversion picture struggles with. A gamma ray of more than 1,022,000 electron volts passing near a nucleus can spontaneously become an electron and a positron. Energy that had no mass becomes 2 particles that do, with no substance having been created. The arrow simply changed shape. Nature does the round trip in both directions and keeps identical books each way. That is what Einstein meant in the last line of a 3-page paper written in 1905, when he said that the mass of a body is a measure of its energy content. Not a store, not a container, a measure. He said it in one sentence, over a century ago, and it has been quietly ignored ever since. So there it is, the hardest case physics has, and the books balance to the last decimal place. We are almost there now. But before we say what the equation actually means, there is one more thing worth knowing, and it is the story of the version of mass that physics itself got wrong, believed for the better part of a century, and then quietly deleted. For most of the 20th century, physics taught something it no longer teaches. The idea was that mass increases with speed. Move fast enough and you get heavier. Approach the speed of light and your mass approaches infinity, which is why you can never quite get there. It was in textbooks, in school syllabuses, in every popular account of relativity, well into the 1990s. There are people listening tonight who were taught it as fact. It has been quietly retired, and the reasons are worth knowing, because they are the same reasons we have been circling all night. The idea is older than relativity. Lorentz, in 1899, and again in 1904, introduced 2 different masses for an electron, a longitudinal one for pushing it along its direction of motion, and a transverse one for pushing it sideways. Those 2 were different numbers. That should already have been a warning. A genuine quantity of substance ought not to depend on which way you push it. Then Tolman, in 1912, packaged the transverse version into a single, relativistic mass, and that is the one that ended up in the textbooks. Einstein hated it. In a letter written in 1948 to the journalist Lincoln Barnett, he said plainly that it is not good to introduce the concept of the mass of a moving body because no clear definition can be given for it, that it is better to introduce no mass concept other than the rest mass, and that instead of talking about a changing mass, one should simply write down the expressions for the momentum and the energy of a moving body and be done with it. He was right, and it took the field another 40 years to fully agree with him. The essay usually credited with finishing the argument was written by Lev Okun in 1989 in Physics Today, and it made the case in modern terms. The case is simple. Relativistic mass is just total energy divided by the speed of light squared. That is all it is. It is a renaming of a quantity we already have, dressed up as a new one. It changes depending on who is looking, so it is not a property of the object at all. It does not behave as an inertia in any straightforward way, because the resistance to being pushed differs along and across the motion. And worst of all, it invites exactly the mistake we have spent 2 hours undoing, that mass is a stuff you can accumulate, that a spacecraft near light speed is somehow becoming denser, packing on substance as it goes. None of that is happening. A proton in the Large Hadron Collider, moving at about 99.99999% of the speed of light, has a total energy about 7,000 times its rest energy. Its mass is 938.27 million electron volts, exactly what it was sitting still, exactly what every proton in your body has right now. What is enormous is its energy. What is unchanged is its mass. Physics deleted the version of mass that behaved like a substance, precisely because it behaved like a substance and mass does not. Now, none of this would matter if the underlying relation were shaky, so let me give you the receipts, because they are extraordinary. We already met the first test, Cockcroft and Walton splitting lithium in 1932, and finding the energy released matched the mass difference. That was good to a few percent. The definitive modern test came in 2005. A team led by Simon Rainville, working across MIT and the American National Standards Laboratory and a reactor in Grenoble, did the cleanest version imaginable. They took a nucleus, let it capture a neutron, and measured two things independently. First, using penning traps, devices that hold a single ion in electric and magnetic fields and measure its mass by listening to how it orbits. They measured the mass difference between the nucleus before and after to about 1 part in 100,000 million. Second, they measured the energy of the gamma ray emitted in that capture, using crystal diffraction to comparable precision. Then they compared, does the energy released equal the mass lost times the speed of light squared? It does, to within 4 parts in 10 million, 55 times better than any test before it. Then there is the question of whether binding energy weighs the same as anything else, whether the 99% of you that is field energy actually gravitates like the 1% that is not. Different elements have different fractions of their mass tied up in nuclear binding. Titanium and platinum, for instance, differ noticeably in this. So if binding energy fell at even a marginally different rate, 2 objects made of those metals would fall differently. The microscope satellite spent years in orbit doing exactly that experiment in free fall, with no seismic noise and no air, and published its final result in 2022. Titanium and platinum fall identically to about 1 part in 1,000 million million. And then there is the quiet institutional admission. In 2019, the kilogram was redefined. For 130 years, it had been a lump of platinum iridium in a vault outside Paris. Now it is defined by fixing the numerical value of Planck's constant, a constant whose units are energy multiplied by time. Mass is now realized in laboratories by comparing it against electrical power on a device called a Kibble balance. The International System of Units now defines mass through energy. Officially, that is not a metaphor. It is how the standard works. 2 other things circulate about this equation, and both deserve a straight answer. The first is the claim that Einstein did not come up with it. There is real history here, and it should be told properly. Poincaré, in 1900, derived that electromagnetic radiation carries momentum equivalent to a mass of energy over the speed of light squared. Olinto de Pretto, an Italian industrialist, published a speculative note in 1903 containing an expression of that shape, embedded in an ether cosmology, with no derivation. Friedrich Hassenerl, a serious physicist who would later supervise Schrödinger, studied radiation in a moving cavity in 1904 and got a relation with a coefficient of 4/3. What none of them had was the general claim. Poincaré's result was about electromagnetic energy specifically. De Pretto's was a guess. Hassenerl's coefficient was wrong, precisely because he was treating a special case rather than a universal principle. Einstein's paper asserts that any body's mass changes by its energy divided by the speed of light squared when it releases energy of any kind whatsoever, derives it from the relativity postulates with no ether at all, and says so explicitly. It is also worth knowing that the loudest versions of the Hassenerl priority claim were promoted in the 1930s and 40s by people whose motivation was removing Jewish physicists from the record. That does not automatically make a claim false, but it does explain why this particular one has been pushed so hard for so long. The second is the free energy claim. that this equation proves unlimited energy is available in any lump of matter, and that this is being suppressed. The equation does say that a kilogram of anything corresponds to 90,000 million joules. What it does not say is that there is any way to get at it. Energy comes out only when a system settles into a more tightly bound arrangement, and how much is available is set entirely by the binding curve, 0.09% for fission, 0.7 for fusion, everything only for annihilation, which requires antimatter you cannot afford. There is nothing to suppress. The vault is real. There is simply no door. So the equation is solid, the tests are brutal, and the fringe claims dissolve on contact. Which means we have run out of places to hide. It is time to say what it actually means. Here is the answer. Mass is not a substance. It is not stuff. It is not a quantity of material that things are made out of. It is a property that all energy exhibits, without exception, wherever and however that energy happens to be sitting. And because of that, nothing is ever converted into anything. Not in a star, not in a reactor, not in a weapon, not in the annihilation of a particle with its own antiparticle. There is no transaction. There never was. Mass and energy are not two commodities with an exchange rate between them. They are one thing described two ways, and the speed of light squared is not a price. It is a unit conversion, the same kind of thing as the number that turns inches into centimeters. That is why almost everyone is wrong about E equals mc². Not because they get the number wrong. The number comes out right either way. They are wrong about what happened. They picture a trade, and there is no trade. They picture two kinds of thing, and there is only one. Now go back to where we started, because it all falls into place at once. A hydrogen atom weighs less than the proton and the electron inside it. When I said that at the beginning, it sounded impossible. Then it became a mechanism, negative potential energy, the virial theorem, 13.6 electron volts. And now, it is not even surprising. Of course it weighs less. Its total internal energy is lower than the total internal energy of the two separated particles, and mass is what we call the total internal energy of a system at rest. The atom's arrow is shorter. That is the entire story. The same sentence, 3 times, going from impossible to obvious. That is what happens when you stop asking how much stuff is in something and start asking how much energy. And the watch is heavier because it has more energy. The kettle is heavier because it has more energy. The box of light has mass because it has energy and no net momentum. The sun gets lighter because energy is leaving. The Earth is 2.5 trillion tons lighter than its own dust because binding lowers energy. The proton is 100 times heavier than its quarks because confinement raises it. Every one of those was the same rule, and I did not have a rule at the beginning of tonight. I had 6 separate wonders. Which brings us to the thing I have been holding back since the 4th part. Every scale you have ever stood on has been reading energy. Not matter, not stuff, not a count of what is present, because that quantity does not exist and never did. The number that appeared under your feet this morning was the total energy content of a particular arrangement of fields and interactions, divided by a very large constant. You were weighed on the day you were born, before you had a name, and somebody wrote the figure down. What they wrote down was an energy. Every doctor's surgery, every luggage scale at every airport, every kitchen scale measuring flour, every stone weight set against grain in Mesopotamia 5,000 years ago. Every single one of those readings was an energy measurement, taken by people who had no idea that energy was a thing, using an instrument nobody had ever explained. The scale was never lying to you, it was just never measuring what you thought. And notice that this is not a correction that takes something away. Nobody has to distrust their bathroom scale now. Every number it ever gave was right. Every diet and every luggage allowance and every dose of medicine calculated from a body weight was correct. because the relationship between energy content and everything we care about is perfectly stable at human scale. What has changed is only what the reading was about. The measurement was always sound. The story underneath it was borrowed from a picture of the world that turns out not to be there. And I want to say something about why this matters beyond being correct. Because physicists prefer a different phrasing, would be a thin reason to spend 2 hours on anything. Under the conversion picture, the universe contains two categories, the stuff and the energy, with a boundary between them where remarkable things happen. That picture makes the world feel like it has a flaw, somewhere down there, past the atoms and the nuclei and the quarks. The actual material finally begins, and everything else is arrangement. There is no flaw. We went and looked tonight, layer by layer, and every layer gave the same answer. Molecules are interactions. Atoms are interactions. Nuclei are interactions. A proton is 99% interaction and 1% particles, and those particles have mass because of an interaction with a field. There is no small hard thing at the bottom holding it all up, which means the solidity of the world, the resistance of a table under your hand, the weight of a book, the fact that you do not sink through the floor, is not the solidity of substance. It is the stubbornness of energy in particular arrangements. The universe is not made of things that have properties. It is made of properties, all the way through, and thing is the name we give to a pattern that holds. Let me leave you with one puzzle, because it is the best test I know of whether this has actually landed. Suppose every person on Earth, all 8,000 million of us, picks up a hammer from the ground at the same moment and lifts it 1 meter. Two identical blocks weigh more when stacked than side by side, because the top one is higher and gravitational potential energy has gone up. So, does the mass of the planet increase? Do the arithmetic, and 8,000 million hammers, lifted 1 meter, gain about 78,000 million joules of gravitational potential energy, which is a mass difference of a little under a milligram. But the mass of the planet does not change. Not by a milligram, not by anything. Because where did that energy come from? It came from muscles. The muscles got it from food. The food got it from plants and animals that were already part of the earth. Every joule that went into lifting those hammers was already inside the system, sitting in chemical bonds, contributing to the planet's mass exactly as it now contributes from a meter higher up. Nothing entered. Nothing left. The energy simply moved from one form to another inside a closed boundary, and the total is what the total always was. That is the whole of tonight in one thought experiment. Not because the arithmetic is clever, but because the moment you ask, did anything cross the boundary, instead of, did matter turn into energy, every one of these puzzles simply dissolves. And what is left at the end is a question nobody can answer, which is my favorite way to finish. We know that mass is a property of energy. We know it to 4 parts in 10 million, and we know that binding energy falls at exactly the same rate as everything else, to 1 part in 1,000 million million. What nobody can tell you is why. Why should energy resist being accelerated? Why should energy bend space-time around itself? The equivalence between the two, between the thing that makes something hard to push and the thing that makes it fall, is written into general relativity as a founding assumption, tested to extraordinary precision and derived from nothing at all. And it gets stranger the harder you look. In general relativity, there is no local energy density for the gravitational field itself, which means that for an extended object, you can define the total mass out at infinity, but you cannot always say where inside the object it is. The most familiar quantity in all of physics, the one on the bathroom scale, becomes genuinely difficult to locate once gravity is taken seriously. There is a small, beautiful example of that difficulty, which I will leave you with. In 2015, we detected 2 black holes merging, about 36 and 29 times the mass of the Sun. What came out was a single black hole of about 62. 3 solar masses did not arrive. They were radiated away as gravitational waves, ripples in space-time itself, in a fraction of a second, at a peak power greater than all the light of every star in the observable universe combined. That is the same rule again. A bound system weighs less than its parts, and the difference leaves. Only this time, the difference was 6,000 million kilograms, and what carried it away was not light or heat or neutrinos, but the shape of space. Even that obeys the accounting we have been doing all night with wristwatches and cups of coffee. So we can tell you that everything you have ever weighed was energy. We cannot yet tell you why energy has weight. Thank you for spending these hours with me on the most famous equation in physics and the sentence that has been attached to it wrongly for 80 years. If this slow, unhurried way of taking an idea apart is something you value, a like or a subscribe would mean a great deal. It is a small thing for you, and it genuinely helps me keep making these. And remember, the next time you stand on a scale in the morning, the number looking back at you is not how much of you there is. It is how much energy you are. Good night, and may you never look at that number the same way again.